Ladies and gentlemen, welcome back to another live stream. This is the third part of this stream where we make a math expression parser library, user parser combinators in Rust from scratch. Well, not exactly from scratch, but we're using chumsky library. Yeah. What's up with this guy? It doesn't want to show up. Hold on. Come on. What? Bruh. Oh, this doesn't work. Weird. Okay, it works now. That was weird. Alright, so everyone. Live implementing our, let's just say optimizing my math XPR parser using ConstantFold. Okay, so this is the first time I'm gonna do such optimization. In fact, this whole parser stuff is new to me, so that's gonna be, in fact, that was a lot of fun, and it's gonna be even more fun today with optimization. So yeah, let me pop out the chat. I'm not sure if the stream is fine. Seems good actually, but anyways, let's just start. I think. Alright, so last stream we optimized some allocations pretty much, so, and we improved a bit the error handling. So cargo trouble, we added this error library. We're using that for error handling for our library. Other than that, our example of course have changed. Right now eval instead of in wrapping, we just propagate back the error to the main function, too simply. And yeah, other than that, we have librs. Okay, we just changed the position of these guys, right? And what else? Yeah, and yeah, there you go. This is our evaluation error that we have added last stream, and we have made sure to handle the function error correctly with it in defined function instead of crashing, pretty much. And we also give the user the name of the function that is in defined. And yeah, we changed a bit the tests, but other than that, not much for improving error handling. For optimizing allocations, we have done quite a bit. So first of all, here's what the example looks like right now. We have actually made the state into its own variable right now because we need it in the eval function too, I think, or is it? Why did I do this? I'm not sure. Either way, so we parse with state, we pass in the state, and in the eval we get the result. Eval, oh yeah, there you go, mutable state, we pass in the state, and yeah, and we check the result. Nothing crazy there. And here we actually print how much allocations we have made. Not how much allocations, but like just how much tokens we have pushed into the vector. So, but basically before we had boxes for every single branch of our AST, which is horrible as you can imagine. So I actually made it, the state basically contains a vector of expressions. So, and I basically, when I want to allocate a new thing, instead of boxing it, what I do, I take the current index of the vector, I push self, look here, I actually consume it, I push it into the vector, and then I give back the index to refer to that vector. So I basically sidetracked the borrow checker. I'm not sure if it's a problem, like if it's a flaw of the borrow checker or if it's a skill issue on my side, probably a skill issue on my side. Either way, I didn't want to deal with more lifetimes and references and crazy stuff like that, so I just used the indices of a vector. But though that does have some interesting effects, like I can see how much stuff, like how much tokens are on the heap and stuff like that, which is cool. I could probably easily traverse and optimally traverse the whole tokens that are allocated on the heap and so on. But yeah, anyways. And other than that, is there anything? Right now, yeah, we have just commented out the operator overload and end the test, unfortunately, because we couldn't figure out how to get that working with the new way of allocating stuff, because we need access to the state, which we can't here. Is the stream fine? I'm not sure if it is. But anyways, okay. So instead of box, new box. Okay, cool. Is there anything else? And of course we have just used with instead of where is it? Yeah, fold. Instead of fold L, we use fold L with, so we can get the state of the parser, and we could use it to allocate, right? So yeah. Okay. Map with, folder with, state. And of course we had to change the eval right now. Instead of, you get an expression directly, a box expression, what you do actually is you have to look up the expressions vector for that index that you got, basically, and that's why it got changed. So yeah, pretty cool. We still have the arguments of the function calls in their own vec. I'm not sure if it is even possible to make it in a better way, but well, okay. So today I'd like to do some optimization for the AST, some basic optimization. This is the first time I'm doing this, which is going to be constant folding. So we're basically going to be like, for example, let's say the user have such an expression like this, 320 times 200 times 32. All of these are constants. There's no variables, so we could just calculate this beforehand. So every time you call the evaluation, the eval function, it would be way faster to go through, instead of every time you eval, you have to do these operations once again without any need to do that, right? So you basically simplify as much as possible through the constants that you have, basically. And in fact, if all the terms in the expressions are all constants, then you can basically optimize the whole thing into the actual number, right? So into the actual result, pretty much. There is even more crazier constant folding version, which is called pretty sure it was here somewhere. I think this is the one, sparse conditional constant propagation. Okay, but anyway, let's go back here. Constant folding, constant propagation relates to compiler optimizations used by many modern compilers. An advanced form of constant propagation known as sparse conditional constant propagation can more accurately propagate constants and simultaneously remove dead code, pretty much. Anyways, let's get started into implementing this, pretty much. That would be a lot of fun. Alrighty. Okay, so we'll have, of course, another function, which is called constant folding. I'm gonna disable the AI for now for a second. Okay, did it got disabled? Yes, I did. Okay, cool. Alright, so pubfn eval, pubfn constant fold, and we're basically gonna get basically, I mean, generally I think you would basically just have the expression, which is like the AST, right? Of course we need the lifetime here, and you would have of course the state in our case, since that's where our actual tokens reside. But I would like to actually go further than that and allow the user to use this constant folding every time they have some variable that became a constant at some point in the program. They can actually use ConstantFold again to optimize the AST even more using those constants, right? So I would also include, honestly, variables and functions too, even in the ConstantFold. I'm not sure if this is done in the industry. Maybe, I don't know. But this was an idea that I had pretty much. Okay, so that's great. Okay, cool. So let's start doing this, I guess. Now, one thing, we're gonna have some problem with the lifetimes with the expression here, as you're gonna see in a second. I can't fix it right now and say usize, but I want you to see the problem first, then we can fix it. So yeah, okay, so let's start simple. And by the way, this is gonna be immutable because this ConstantFold wouldn't actually return a new AST. I mean, you can go with that, but for optimization's sake, I wouldn't go with that. So I'm just gonna immutate the AST directly. So I'm taking a mutable reference to expression and a mutable reference to state, right? Cool. So let's start simple by, like, let's say constant propagate the negate thing, right? The negate expression. So like if you have minus minus 1, it would just get optimized into minus 1, you know. So how we can do this? Well, of course, as always, we're just gonna import all the expressions to make our typing life easier. And we're gonna match on the expression. Oops, what's happened? Match on the expression. Okay, cool. Missing match arm, type is non-empty. What? Anyways, yeah, I can do this basically would do everything, but let's start simple. So we're gonna ignore everything else, and right now we're just gonna focus on one little simple thing, which is the negate. I think that's the simplest to do. But actually, before that, we have to think about our base case, because this is gonna be recursive. Our base case is gonna be if you have a number. If you have a number, then you're done. Also, if you have an identifier, then you're also done. So we can do this, and we don't care about the value, I think, yeah, because, you know, we're not returning stuff, we're just mutating stuff if it needs optimization. Otherwise, we just let it alone as it is. So if we have a number or identifier, we just ignore it. Yeah, you know, that's the base case. So we just return from the function, we're done. Cool, but in my case, I'm gonna go even further, and instead of returning in terms of identifier, I'm not gonna give up there, honestly. I'm gonna take my name of identifier and check if in this ConstantFold function, do we have, like, did the user define that variable for us? If they did, then we can, you know, turn it into a number so we can optimize even further. So what we're gonna say is state dot expressions, and we're gonna use our hold on, state dot expression, right, is equal to, you know, it's mutable, is equal to variables, right, dot get get name of the identifier. Of course, if it does exist, so if we find it, then we're gonna set it. So if let some value is equal to that, then we could basically, if let some value is equal to variables dot get name, we're going to say expression is equal to number, and we're gonna give it the value, basically. Expected immutable found. Yeah, we're gonna mutate this by dereferencing it. Expected F64 found. Yeah, makes sense. Let's do this, and there you go. Pretty much. That's how you ConstantFold identifiers. So you just replace them with so just like what you would do in mathematics, you know. If you have a number, yeah, that's done. You're done with your optimization. That's the result, right? If you have an identifier like x, right, you'd have to, if you have, you know, if you have the value defined at that point, then you could go ahead and optimize it into a number, and there you go. Now, that's still nothing fancy yet, but where it becomes a bit fancy is when you take into account the negate function, which takes a usize, which is like the actual expression index, right? Or you can think about it as the reference. Okay, so how are we gonna do this? Negate expression. So the first thing, before we can ConstantFold this expression, we have to make sure to recursively ConstantFold that expression itself. If that makes any sense. So what I'm gonna do right now, first of all, before doing anything, I'm gonna make sure that the expression I'm looking into right now is already ConstantFolded first. Of course, it's gonna go ahead and recursively do that until it finds a number, or basically cannot ConstantFold anymore. Okay, cool. Well, the first thing that you're gonna notice here is that this ConstantFold takes a mutable expression, not a usize. So we gotta resolve this using our state, right? So state.expressions dot state.expressions expression like this, right? And we gotta actually give a mutable reference to this. And here where you're gonna notice the problem. So the type expression cannot be indexed by mute. Oh, hold on, what? Oh, I think I just do this, right? Okay, cool. And here we pass in the state. Well, we already got mutable state here, so yeah, that's good actually. Cannot borrow state as mutable more than once at a time. Second mutable borrow occurs here. So this is the problem. I'm not sure if there is another way to fix this, but this is the problem that I was talking about. So here we're trying to give a mutable reference to a state, right? But we're also given a mutable reference to one part of the state once again. So we're getting two mutable references, which of course the borrow checker wouldn't allow, right? So that's why it would be better to actually use usize here. Right? And let's go. So now we just have to make sure to say state.expression. And honestly, let me just make a function in the state, impulse state, and let's make a fn. What should I call this? Maybe I'm not sure. Let's maybe call it get. I don't know. And you would basically get an expression index. It's gonna be usize, right? And it would give me back, well, it depends. Honestly, I'll just do it manually. I'd have to make multiple functions for every single case anyways. Type usize cannot be dereferenced. Alright, hello Henrik Pereira, welcome to the live stream. Alright, so let's fix this right now. We're gonna go with state dot expressions, right? Dot, well, not dot. We're gonna go with the expression here as the index, and there you go. And the first thing got fixed. Second thing, we're gonna do the same here. So state dot expressions expression is equal to number value. And now, instead of doing this weird thing right here, we could just return expression directly because it's already usize, right? So ConstantFold expression variables function state. And now we don't have that nasty borrow checker problem anymore. And okay, cool. So, but we have yes, we have tried to ConstantFold the children elements of this, but like of this AST, but we still haven't done the ConstantFold for the negate itself, right? So let's do that. So after ConstantFolding our children, what we're gonna do is, so if let sum, or is it? No, if let number, right? So if we can find a number in the expression after we ConstantFold it, meaning that we have optimized it completely. So state dot expressions. Oops. What? Why? Weird. Anyways, and say dot expression, and we're gonna get the expression here, I think. If let number, oh, my bad, I see. So here we're gonna get the value, right, is equal to this, and there you go. So after we ConstantFold, if we find a number, there you go. Now we could just return or mutate that expression. But we do need to get the original expression though. I'm just gonna call this honestly A. Gonna ConstantFold A. And expression A. And if that's the case, then we're basically gonna say that state the expressions. What is it called? Yeah, expression is equal to value, and there you go. So we mutate it. Mismatch types expected. Oh yeah, my bad. Negate value. Expected use size found F64. Oh, my bad. Minus value, right? Is it expected expression? Oh, I see. So this would become number minus the value, right? So if we, after we ConstantFold A, if you find that there is a number right now after the folding, we just mutate this negate AST into a number minus value, right? So there you go. That, as simple as that. That's how you negate it, right? Cool. Let's try this out actually now. Let's try. Now there's one little problem here that if you didn't notice, because the borrow checker doesn't got our back right now, because you know we're sidetracking it using indices into a vector. If you notice, there's actually a leak here. We have made a leak, right? What is that leak? Is that if this expression that is here before this is pushed into the vector, it's just going to be dangling at that point, right? So like it's going to be leaked. No one is using it, but it's still there, right? So honestly, I wouldn't really like care about that a lot. So our vector is kind of like a bump allocator, where we just like, while we're doing our operations, we just keep on allocating, and when we're done with it, we just, you know, deallocate everything. But I think maybe we could add another, if we are concerned about that, we can add another vector to keep track of expressions that we do not need anymore, right? So where's our state? So you would, and basically after that you would kind of like do some garbage collection. Essentially you would walk the AST, and of course on user request. If he wants to clean up and, you know, free some memory, then he could basically call that function and do the trick, right? I don't know what to call. Let's see, I guess cleanup maybe. And it would be an expression src maybe. There you go. All right, cool. Or actually not expression, my bad. No, it's gonna be usize. So the indices that we want to clean up. Okay, cool. Righty, great. So now, before we do that, where is it? Where's the constant? There you go. Okay, so before we do this, we can say that self, well, not self, state dot cleanup dot push, and then we can push in the index, and in our case the index is a, right, because it was negate a. So yeah, so that's not needed anymore. State dot cleanup dot push a, and then maybe we could have another function called maybe cleanup, and do we need the src? I don't think so, no. Let's see. So we're gonna go through the state. Do we need the expression? No, we don't. I think we only need the state, pretty much. Beautiful. And honestly, I should probably put this into into maybe a function. Where is the state? Impl state. Oh, I don't have an impl. Oh, I removed it. Okay, gotcha. Interesting. Okay. So let's impl state fn cleanup, and you would get mutable self, right? And there you go. Now we're gonna go through, but actually we gotta be careful about this. Yeah, we gotta be careful about this, because like if you remove some item that is still being used by some another expression, then you know the order would mess up for the items that are after it, right? Because they would all be pushed left. So you gotta make sure that those expressions aren't used. Interesting. Well, I guess we gotta care about that later on, right? So implicit deleted lifetime, okay. Okay, so we can care about that later, but for now I think this should be good to go. All right, let's see. Let's go to our basic.rs right now, where we have a simple example. Well, actually it's not that simple of an example. Let's make another example, I guess, simple.rs, and let's pretend we're using our own library right now. And I don't need, hold on. I'm just gonna have a simple thing, let's say -1, right? And I don't need any variables right now, I don't need any functions right now. We're just gonna say default. We don't care about those right now, something very simple. And let's just remove these two. Well, actually only this. And I mean, you could just print the whole state, really. I think doesn't implement debug. Well, implement it then. Well, like it can't do it itself. Okay, so debug, and there you go. So let's see our state right now. If we actually run the simple example here, this is what we get. This is our ASC. It's a negate 0. Result -1. So this is the result of the evaluation, pretty much. -1, which is correct. And the state though, so it's 0, so it's looking at the first expression in the vector, it's referring to that. So negate 0, and 0 refers to this number 1, so this is negate number 1, right? We probably gotta make a function to print this correctly, but yeah. So, okay. Now, what if we do ConstantFold? And in fact, if I show you right now, if we do a lot of minuses here, look at what's gonna happen right there. So look at that. All these expressions right now. So negate 10, negate 1, negate 0, negate 1, negate 2, negate 3, negate 4. So all these tokens right here, right? But if everything goes well, then if we used our ConstantFold and let's just basically copy this. Expected types. Oh yeah. So right now this would actually need a use size, not an expression directly, not a reference to an expression. So what we could do, again, just like what we do, push, well, not really. I mean, we could just say ast.boxed, yeah. And then we could give it a mutable state. But then, of course, it's not going to like it, because we're having multiple mutable references first of all here, and here we're actually borrowing off a moved value because the AST got moved when we boxed it. The right way to go about this is to simply say boxed here instead. Boxed here, right? And here you would pass the AST. So the AST right now is just the use size, right? It's just a simple thing that you could pass around. And eval here you would need to essentially resolve that reference or deref. So okay, how are we gonna do that? Well, to simply not self state dot expressions dot get ast dot inwrap. We know for sure that that exists there. And cannot borrow state as mutable because it's also borrowed as immutable. Okay. Really? Huh. Interesting. What if we debug the AST afterwards? I mean, I see what it's... Hold on a second, actually. Why the eval? Yeah, I'm pretty sure we have changed this. Yeah, it doesn't need a... it doesn't need a mutable reference here. Yeah, my bad. We have changed that before. We just needed that before for something, but yeah. Anyways. Let's see right now what we got. And this is our result, of course, minus 1.0. The AST is 11, index 11. And the cleanup, we can clean up all of these nodes, basically. So, okay, result. Hello, Mr. Kodatak, would you ever consider a C++ stream? Sure, I just need ideas. And welcome to the stream, by the way. I just don't have ideas for a C++ stream, pretty much. But I can teach you guys a bit of modern C++ 23. Other than that, IDK. And maybe some modern CMake too. Yeah. And some templates, possibly. But, well. Alright, so let's see what we got. AST11. Let me first of all make this a bit cleaner. Hold on. Cancel. And I desperately need some better way to actually print this. Okay, so we can clean up all these nodes. And here the AST is number or index 11, which is, it's probably going to be the last one there, maybe. So number -1. So you notice that it's got ConstantFolded there. Though honestly, we really need some way to print this to see the whole thing instead of just seeing indices and stuff like that. That sucks. So let's do it. Okay. Alright. Where is impl state again? Huh. Bro, what the heck? Didn't we have a cleanup function? There you go. Oh, okay, gotcha. I see. Alright, so after the cleanup function, we're gonna have a print function actually. Not in the state though, in the expression, my bad. But like, you could either have it on the state or the function. Which one should we do? I think honestly, I think the state would be better. So maybe print and then expression or AST. You would get the U size, and you need to print that. Okay, cool. So let's go ahead and do this. So of course we need self, reference to self, and we're going to go ahead and say self.expressions expression, right? And we're gonna match on that. Missing match arm multiply. Let's fill everything, right? And let's go. Okay, so here we got number F64. Well, not really print. Maybe we want to actually toString, right? Kind of. Do we want to print it or make it into a string? I think printing it maybe would be simpler. I just realized that we're gonna need to print a tree. Interestingly. Okay. Okay. So let's do that anyways. So here we're gonna get our value. And let's just print line value, pretty much. Format argument, oh yeah. Print line value. And here identifier, you actually also you get like a name of the identifier. And so here we would also print just the identifier too simply. Okay, and negate. Well, actually, don't we better maybe print this into an expression? Turn it back into an expression even? Yeah, that's actually better. Well, the real question is how to do that. Well, we gotta start somewhere. So let's use print though instead of print line. I'm not sure how this would go, but we'll see. And here we're gonna have our expression, or let's just call this A, right? And we're gonna actually resolve, well, basically we're gonna, yeah, print. First of all, we're gonna print a minus, right? And whatever there is there. And here we're gonna recursively call print. Pretty much print A, I think. And self doesn't implement stdfmt. Oh, my bad, I see. So this should actually really return string. Otherwise we could also go with a cow, but it's not really gonna make a bunch of difference because we're gonna make a lot of strings anyway. Other than the identifier, this is the only one that we could just pass in directly instead of having to create a new string. But let's start simple, bro. Let's start simple with just a allocated string. And instead of print right now, we're actually gonna say format. And so this is essentially format, not print right now. Self.format A. A B B A B B B. Or honestly, we could also not really, never mind. Call, and here we're gonna need the, yeah, we also have this call name, yeah, interesting. And we have the expressions, the arguments, right? So that's interesting. This pattern, oh yeah, I remember this is a tuple actually. There you go. Well, I don't want to move it. Can I just get a reference somehow? Interesting. Cannot move out of index. Oh, my bad. So I should just do this, right? Cool. All right, great. So format minus. Well, we could just return name directly here. Here, though, we're gonna need the format. Or we could just simply turn it into a string directly. Right? Though, honestly, to not need to allocate this, I'm just gonna go with a cow. So, how do you even do this? I think like this. Cannot find a cow. Quick fix, import. There you go. Cool. So now we're just gonna make sure to say cow. Or honestly, I'm gonna use all the cows. All the cow variants. Right? And we're gonna go with, so here we actually have an owned string, right? So owned. Here we got a borrowed. So we use a cow here, since we can either have an owned string, so an allocated string, so a new string, or an already allocated string, or just referring to it. So using a cow, we don't have to actually allocate this name again for no reason. Though, can I actually say just .into instead of .own, .borrowed, etc.? I'm not sure if you can do that. I mean, that one worked. What about this? Did it work? This one doesn't seem to work. Interesting. Well, honestly, I'd rather just do it like this anyways. Okay, great. So here we got an owned string. And we got format self.format. Consider dereferencing the borrow. Expected use size found. Huh. What? So, oh, yeah, I see. Okay. And now we're gonna basically do the same thing with the other ones, kinda. Owned. Okay. We're not gonna be able to actually benefit from that cow here in neither. We can only benefit from it here. Because we're gonna have to append the arguments, and so we have to allocate a new string anyways. So let's say right now, so instead of minus that, we're gonna say plus that. And in fact, one thing, because we do not know what is the actual precedence that is going on there, so we'd better off doing it like this to make sure, maybe. But let's keep it like that for a second anyways, and see how it turns out, so I don't fix a problem that doesn't exist yet. Copy paste job, And finally here, we're gonna say, well, hold on, subtract, there's gonna be minus like this, multiply this, divide this, and pow. Okay. And here the call. We would have, oh, interesting. So how do I, okay. Well, for now we can make use of the vector debug print, possibly. Yeah, I think so, for now at least. Okay, cool. So self.format, name. Well, here we don't need a format, it's just name, pretty much. And the second one is here. So, well, actually, hold on, it's even crazier than I thought. Because yeah, you're gonna get a vector of arguments, but those arguments needs to be formatted too. Interesting. Gotcha. Okay. All right. So arguments.map, I think. Map. So you get your argument there, and we need to self.format the argument. The method map exists. Oh yeah, this should be turned into an iterator. We could just consume the arguments vector because we don't need it anymore. That's why I said into iter instead of iter. Mismatch types, expected use size, found expression. Oh crap. Oh, what the heck? What is this, bro? Man, I hate this when it pops up. I don't even know how to. Freak. How to close this thing? What the heck? Man, this sucks so bad. There's only open here, there's no close. Such a bad UX, bro. Hold on. Visual Studio Code. How to close. Blame, git blame. Okay, so I just had to click that, interestingly. Yeah, I would have figured that out, right? Anyways, how the heck are we getting an expression here? Oh, I see. Gotcha. Okay, gotcha. So Victor actually have expressions instead of interesting. Well, that's gonna be fun. So to use my format function right now, I have to allocate those expressions. Again? Yeah, that sucks. Okay, let's just do as a temporary solution for now. Argument.box state. Where's my state? Oh, well, it's self. And what the heck, expected? Oh crap, we're gonna need mutable access. Okay. Okay, great. Okay, amazing. Yeah, no thank you. Would it be any better if I just took expression as a reference instead? Hopefully. I have no clue. Man. Man. Okay. And then hopefully I wouldn't have to do this. I would just return the argument directly. I would just give out the argument directly, yeah. And here, now we gotta do that stupid thing of saying, you know, self-expressions A. Or isn't it? Yeah, and I have to do this. Oh, that's super ugly. Expected expression found. Oh, yeah. Please just work. Self.format. Well, let me just copy this honestly and paste. Oops. Paste it there. Paste. 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 Yeah, those function arguments are getting on my nerves right now. Because they're basically allocating their own vector, which suck. So I cannot use those indices on them. Anyways, explicit lifetime required in the type of expression. Oh crap. Okay, I see. Is that what you need? I think so. Alright, so let me just make sure this get fixed. Alright. Alright, let's try this out, hopefully. Let's try this out. So instead of doing this weird thing right here, well, let's just say state, well, print line, yeah. State.format. Well, of course we need the format string. Okay. And format is private, sure. Public, please. There you go. So here it expects one argument. Cool. So the argument would be self.state, well, state.expressions. Oh my. AST, okay, cool. And this is what we, well, hold on, what? Yeah. This is what we got, -1. Alrighty, cool. But if we don't ConstFold this, so from this to -1 directly, if we don't ConstFold this, then this is what we get. There you go. Nice, lovely. Okay, cool. So let's go to the next step, I think, where you would have, let's say, 1 plus 2. And right now, the current ConstFold doesn't, of course, fold it yet. it's just 1 plus 2. But if we implement it right now, so here, by the way, you're seeing the format of the AST that we have just implemented, right? So let's actually optimize the add right now. Add AB, right? So first, before we can optimize this one, we have to optimize the children of this AST. So we gotta make sure to basically ConstantFold A and ConstantFold B both. Here we only have to ConstantFold 1 because we only have 1. So okay, cool. And then we can do our job. And our job is this, though it's gonna be a little bit different though. So this is basically your value 1, and this is your value 2. Is this how it's done? Maybe I think we need a tuple here actually. Okay. Is that how it is? I guess so. Okay, cool. So if we find both value 1 is a number and value 2 is also a number, so like both A and B are numbers after the constant folding, then we could basically do number value 1 plus value 2. Or a better name would probably be LHS, RHS, so left hand side, right hand side, right hand side. But you got the point. And there you go. And cannot move. Sure. There you go. There you go. So if both both A and B have been constants folded to numbers, then we could just optimize this into one number, which is LHS plus RHS. So now, remember that in our example right now, we get 1 plus 2, but if we run this, we get 3. So we got constants folded into 3, because these are both constants. But of course, if it is 1 plus x, it wouldn't be, because they're not both numbers. In fact, in this case, we get undefined variable, but that's just because we're trying to evaluate it without the variable being there, right? So I don't care about evaluation right now. We're optimizing the AST. There you go. So 1 plus x, it doesn't get constant folded. But if I say 1 plus 2, 3, if I go on, of course it would work all the way down. There you go. So right now our whole AST here after constant folding is just this, the evaluation of this directly. So, and you may say, why do constant, so like this is kind of similar to evaluation, right? So why do constant folding in the first place if you can just go through the tree? I mean, you're going through it anyways in constant fold. Why go through that effort and not just go with eval directly? Well, the thing is, like this AST that we have just made and that we constant folded, we can actually evaluate it multiple times, and every time we're gonna have less time going through the whole tree for evaluation. So basically we're reducing time of the evaluation by simplifying the AST and constant folding, right? So instead of every time you evaluate, you go through all of these operations. Right now it would just give you the number directly, 10, right? So there you go. Without the constant folding, there you go. With the constant folding, there you go. But you got the point. Okay, so let's go to the next step. Now the only thing that you can see here, like the one thing that you have to realize here, is that we're only doing this if we have number in LHS in the left hand side and in the right hand side. If we only have one of these numbers, then we don't do anything about it, right? But the thing is, you can have something like what if you have x plus 0, right? So you can easily just go ahead and make this into x, right? You don't need that 0. So let's do this. Like, you don't have to know. Now there is some problems with the floating numbers, like and not a number, you know, NaN, and then some other stupid, well, there's also infinity for floats and such, which makes this buggy. Like simplifying, like do constant folding on such cases kind of buggy, but I don't really care, honestly. I'm just gonna do it anyways. Right, since most of the time, as long as you don't have not a number or infinity, you should be fine, which you shouldn't most of the time. Anyways, so great. So how we can do this? So of course I'm gonna say else if, because I only want to check this if this failed, because if this is successful, then there's no point in you know, checking if there's one number, because there's already two numbers. So if there is x and hold on, what I'm doing, and I don't care about the second one, right? Hold on, I'm trying to think. What if I do this equal to this? I mean, actually, can't I just match this, really? Hold on, let me try to match this instead. Maybe that would be better. Match, okay, of course, on this guy right here. Well, this whole tuple, actually. Now, if we have this, then you know what to do. We gotta do this. Great. Ensure that all possible cases are being handled. We're not gonna care right now about those. Okay, cool. So look at that hot match statement. Pattern matching. Great. So we don't need this anymore. Let me just verify that this works real quick. Oh, never mind. Anyways, so let's just right now copy this, and if we have LHS only, or let's say actually, and number 0, my bad, number 0, right? Hold on, what's up? Maybe I need the float right here. Okay. Though I could also say number x right here, because I do want this to work, right? X plus 0. But also 0 plus x also should just result in x alone, right? Should be folded into that. So what I could do with the cool Rust pattern matching, I could do this, right? At least I think so. Unless if I'm wrong. Then I should be able to do this. There you go. Cool. So if number x here, or number 0 and number x here, then we're gonna say number x directly. There you go. Cool. Or we could say value, I guess. Okay, what is the problem here? I cannot find value. Oh yeah. Yeah, let me do this, and there you go. Good. Now this should be able to be constant folded, optimized into x. If you run this, we're gonna get, oh, what? We still having 0 plus x? What? What do you even mean? Did I miss something? Huh. Oh, my bad. I'm actually saying number value here. But isn't that what we want? I mean, yeah, number value, or I mean, Interesting. I see. So isn't that kind of pointless? Yeah, this one actually would be catched by number. What I really want here is actually identifier, my bad. Identifier is what I want here. Because that doesn't make any sense. It would be done by this anyways. Right? So yeah, good. Identifier name of the identifier. And same thing here. I'm not sure if we still need the dereference there. Doesn't seem like so. Okay, good. Now this should actually work. Let's see. This should give us back x. What are you even talking about? Oh, okay. X plus 0. And there you go. It results in x. 0 plus x. X. And let's go. So you could just add zeros however you want and it would be optimized out. Of course, without the constant folding. There you go. You have to evaluate this whole thing all the time. So that's great. Let's optimize the other ones. Okay, cool. Now, oh, by the way, I forgot one little thing here. Yep. We have a little leak here. Let's push B2. I should honestly make a function to make our life easier here, but anyways. So sit.cleanup.push A and push B. Other than that, this is great, I think. Alright, great, lovely. Alright, what's next? So, is there anything we could do for adding stuff? I cannot think of one right now, but there you go. So that's the additive identity. Great. So let's go right now to the multiplication. Now in multiplication, if you have 1 times x, right, or whatever, you can just get rid of this one, right? You can just get rid of that multiplication. So let's do something similar to add right here. Of course, constant fold in A, constant fold in B. And honestly, can't we just do both on the same place? But maybe it's gonna become some spaghetti there. Good question. I guess I would honestly rather not, but yeah, anyways, so here we got the multiply A and B. Of course, you've got number, then multiplication there. Otherwise, we go with 1 here, 1 here, right? So that's the actual identity of multiplication. And there you go. And of course, the order doesn't matter when it comes to multiplication and addition. So that's great. I think that's basically it for that one. So if you have 1 times x, it should simplify to x. There you go. Great. If you even have 1 times x plus y, that would still work, yeah? Interesting. Actually, that doesn't work. Okay. And yeah, if we want that to work, we actually gotta make sure to... But hey, can't we don't have to make it an identifier, don't we? Do I have to actually make a branch for every single variant for that? Or am I not thinking straight? Actually, I don't care what this is, right? It could be anything. I don't care. So, you know, expression, right? I really do not care. This whole thing, right? And then oh, well, we already got that. All right, let's call it XPR then, or I don't know. Anyways, and we could just make it XPR directly. Mismatch types expected expression found reference expression. Mismatch types expected expression found reference. Okay. Can we clone this? Yeah. Can clone it. Cool. But hold on, if we clone it, oh crap, that is kind of problematic maybe. Actually, no, I mean, we're still having this here, right? Yeah. I think that should be fine, yeah. Other than we may be cloning a function called arguments, which is a vec. Can we do it another way though? Good question. I don't think there's a better way to do this. Not really. Anyways, let's just say XPR clone here. And now this should actually work. Hold on, this one, right? So let's see. Oh, really? Actually, I think we've done this only for add, right? Yeah, we've only done it for add. Okay, let's do it. Right, so if you have plus here right now, that actually would go away. What? How? Really? XPR number 0 or number 0 XPR. Don't get it why it doesn't work. It should work. XPR clone. Something fishy going on here. Alright. So what the heck is going on here? Identifier X, identifier Y. Add 0, 1, add 2, 3. And no cleanup. What? That's weird. Okay, let's go with the simpler thing. Let's go with this. That doesn't work either right now. My bad. Alright, gotcha. Why? It should be 0. Man. I'm stupid. There you go, that actually works. X plus Y. My brain have crashed at that. Forgot that I didn't change this to 0 instead of letting it as the multiplication identity. Well, crap. Okay. So let's now do this. Okay. So here it's gonna be XPR. XPR. Alright, cool. XPR.clone. And there you go. So this also works right now. 1 times whatever expression would give you x plus y. Like it would give you back that expression without the times 1, you know, which is great. So if we have even plus 0 here, the AST would get ConstantFold into x plus y too. Amazing stuff. Lovely. Okay, cool. Cool. Anything else? I think right now let's go with the subtraction, right? I mean, honestly, at this point, let me try to let the AI do the job. I have already established the pattern, you know, so it may do a good job here, you know, implementing the rest instead of me just copy pasting stuff up. Though I should probably abstract this into functions, but I'm super lazy right now. Okay, so subtract. Subtract, ConstantFold, state cleanup, push, great. And notice here that the AI have noticed that, well, the subtract, the order doesn't matter. So of course we cannot do both, you know, we can only do this, right? So XPR minus some 0. Then we can do this optimization. Okay, what about the division, bro? Come on. Divide, yeah. Pretty much kind of a similar thing there. What are you using for AI Cody? I don't know. I use it like, for example, here I had a pattern that I would just copy paste, you know. It's a tedious thing. I would just use AI for it, really. Or it's kind of like a glorified search engine or advanced autocompletion. However you want to take it as. But yeah. The only problem with AI is that you have, after it generates code for you, you have to proofread after it, right? So you have to make sure it didn't do something stupid. But other than that, it's pretty good. Like for example here, it didn't dereference the RHS. But other than that, it's good. So left hand side. So if we have number and number, we just, you know, evaluate it. LHS, POWF, RHS. If we have though power off like to number 1, then we would just, you know, anything power like, what is it called? Exponents or power? I don't know. I guess power. To the power of, right? Yeah, I think so. So any expression to the power of 1, it would be itself. Hold on, what the heck? Hold on. Yeah, pretty much. Pretty much. Yep, makes sense. Okay, and anything to the power of 0, of course, it would be 1. It would be number 1, so that's good. Unless if there is some exceptions I haven't, other than the floating exceptions that I don't care about. Though I should probably count this up, just in case if someone some optimization here may produce incorrect results. If the expression contains side effects, that's true, but I honestly don't care. This is a mathematical expression parser. We don't have any side effects. It's all pure. So, I mean, you can make a function and basically that function would do side effects. But, I mean, that's your problem at that point. Not my problem. But maybe there is a way to actually enforce that in the type system in Rust. I'm not sure. Anyways, if the expression contains side effects, that's good call from the AI, but also, and if the not really, no. If the value, if one of the floating, exactly, yeah, there you go. That's it. If the one of the floating point numbers is NaN or infinity, so not a number or infinity, So yeah, just leaving that note there. So anyways, all right. Yeah, as I said, I could have actually probably put it all of this into one, you know, like I could have said add AB or multiply AB and so on, but honestly it would become a spaghetti real quick, I think, so I'd rather just separate concerns here maybe. So yeah. And finally, well, not final, or is it call? Currently we're not doing anything for call, though I'd like to actually, like if the arguments are constant, you know, then we can just call the functions. Of course, as long as they're available in our ConstantFold, in this call of the ConstantFold. But yeah, you can, like, let's say you can actually call ConstantFold multiple times, right? And give it every time, give it like let's say you have a REPL, okay? And then the user is can define names, can define variables, right? So when the user, let's say, give or assign a number to some variable, then you can call ConstantFold again and provide those variables that got resolved to a certain concrete number, right? And there you go. You would optimize it even further, so the next evaluations would be as fast as it could be. So there you go. Anyways, so yeah, I'll try to maybe do this call. That would be great. Is there anything else though? Is there anything else that I'm missing? Let me remove this thing here and it would tell us if we're missing anything. It doesn't seem like it's complaining, so I would guess no. Alright, so the last thing is the actual call here. So name of the function and the arguments, right? And what's up? Data moved here as type Vic expression, which does not implement the copy trait. Can we just take a reference of this or something like that? Oh, I guess you do it like that, maybe? Okay, cool. Now I know what a ref is for. Interesting. Okay, cool. Alright, so we're gonna go through all the args and basically make sure to ConstantFold all of them, and then we're gonna make sure that all of them got, you know, but hold on, yeah, okay, so let's actually start doing that, right? Yeah, exactly, good job. For argument, but for arg and args, ConstantFold arg.boxed. Why box the argument? What the heck? It's thinking that it may be usize, is it? Hold on, mismatch types. Expected usize found expression. Oh, ConstantFold takes usize. Ah, I see. So that's right. That's correct, actually. Cannot borrow as mutable because also borrowed is immutable. Oh crap. Oh, really? What? Confused. Should I actually box the arg here first, then do the trick, maybe? So we can drop the immutable reference? Maybe? Cannot mutate immutable variables. Yeah, we do not have access to mutable state. But why you need that? Oh, we already have mutable state? Really? What do we even use that for? Is already mutable borrow. Well, I'm quite confused now. Gotcha. Can we clone this? Huh. Okay. What? Playing with the borrow checker. Oh crap. Cannot borrow state as mutable because it is also borrowed as immutable. Okay, what if we done this? What's up? Okay, let me see the whole error. So immutable borrow occurs here in line 261 here. Immutable borrow. Immutable borrow. Are you sure about that? We don't have a borrow here, don't we? Watch. Anyways, immutable borrow later used here in arguments. But I guess we cannot use this, right? Am I correct? Okay, that sucks. Can we tell it to clone it somehow? Or maybe I could even clone it for now to sidestep this for a second. Can I do this, please? Please? Okay, arc.boxed state. Alrighty. Hold on a second though. No. If I actually box this argument, that means I'm not constant folding the original argument though. Or isn't it? This is kind of weird. So I can only use ref here, right? Yes, I think so. Or am I incorrect? Hold on. So if we go back without the ref, if I try to, yeah, it wouldn't work. But why we're not using a reference here already anyways? Oh crap. I see why. But is it only that we need the dereferences all of there? I mean, we could do that if that's just only the problem. Okay. Syntax. Oh. What? All right. Anything else? Oh my god. Crap. Hopefully this would at least help us. What? This never ends? Cannot borrow state as immutable. Oh crap, never mind, bro. Oh, this suck. This suck. Okay. Yeah. Yep. But I guess I'll just try this anyways and find out. Interesting. But man, we're actually cloning this thing. Walaikum assalam. Whoa, GG Kieran, welcome to the live stream. Because ConstantFold takes state as immutable, and here we're trying to, yeah. Interesting. Yeah, anyways, let's see, I guess. So yeah, this simplifies to x plus y. Okay, let's try something interesting. What if we have fxy, right? Or f of x, anyways. Oh, it's actually saying map error. Okay, go to the format function. Yeah, we have still not joined these. Okay, so we have a bunch of strings, right? Well, a bunch of cows, but whatever. Can we actually collect them into one string? Can we use join maybe, or? It seems like we have to maybe collect, well, can we actually collect into string directly and it would join them maybe? Is that even possible? Maybe? F of x. Interesting. Well, honestly, yeah, basically my solution or my idea was to basically use a vec instead, actually, and it would basically give me a format there as a debug. There you go. Yeah, that's what I was thinking. It's not perfect, but should do the trick for now at least. So yeah. Well. Anyways, let's try this out, right? So let's say we ConstantFold, and we actually do have the f right now. So how are we gonna add it? We're gonna add it here, right? Hash. Whoa, come on, bro. Hash map from. And this. Oh. How do you, okay. And here we could put our thing as fn. Mismatch types expected. Oh crap. Well. Mismatch types. Oh. Oh, I see. Oh crap. Okay. There you go. Okay, let's see. Oh, what? It didn't simplify. It does have that. I mean, yeah, makes sense. It does have fx, right? It does have the definition of f, but it doesn't have the definition of x. So let's give it that. Why not? Because to be able to constant fold, you know, f of x, you need f, but you also need x too to be defined. So we could maybe do this. Interesting. Still printing f of x. But hold on, well, we haven't done everything yet though, my bad. So yeah, after constant folding all the arguments, did the AI did it well? No clue, let's find out. Doesn't look that good already. Well, let's see, if let some f equal to functions get name. Yeah, if we find the name of that function there. Actually, I mean, if we don't have, instead of going through the arguments, first of all, let's see first if we have the f. Because if we don't have it, this is pointless, right? And then arguments iter map if let number equals state expression, value return none, collect option. Interesting. I would rather do it on my own, honestly, for now. I'm gonna disable completions, and yeah, let's take this here. So if we do find the function, then we can go ahead and try to constant fold all the arguments. Actually, we can do this here even. Maybe? Can we? No clue. And I don't know why it's collecting this craziness right here and stuff like that, but let's do this for a second. And let's just constant fold. So after constant folding, we're gonna return, well, if let number is equal to value, right, is equal to argument. I don't think this would work, honestly. If let some args, that's weird. Why are you checking for? Oh, I see. But anyways, so now if let number is equal to arg, then return some value, I think, else none maybe. So too simply, can we do this better though? Well, isn't that just arg dot? What? Well, anyways, else none. And other than that, let some args. Oh, yes, I see now the AI what it was trying to do. So it's basically collecting those options into an option. Was that actually correct? How do you do this again? I've done it in before. It was kind of like collect. There you go. So something like this. Right, instead of result, of course, in this case we just have an option, I think. enum takes one generic argument, but two generic arguments were supplied. What? Oh, I see. And yeah, that should do the trick, I think. Great, 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 great. So if let's sum args, then state expression is equal to number f args times expected struct found struct vec. Oh, there you go. Oh crap. Here we go again. Oh man. Can we just copy every single element there? Well, not copy, clone maybe? Would that help? What? And a sock. I guess we can come back to it later on, honestly. This is really sucky. Anyways, ensure that all possible cases are being handled. Okay, cool. Cool. Here, we're just gonna say, well, let's just actually leave it like this. So yeah. Oh crap. Well, you know what? Just remove it. Borrow checker problems. Maybe a skill issue, or my brain is tired right now. Either way, that should be it for this one for now, at least. Maybe there is a lot more that you could do, actually. So like you could go as much as you want, but of course you would keep on adding more code. So like for example, let's say in like you could look for, let's say in add, okay? So for example, let me give you an example and maybe you're gonna see the pattern. So let's say we have some so expression A and expression B, add. Yeah, so okay, if we have some negate, right? So negate A, or actually negate B, is it? Hold on. Yeah, actually no, if you have A and negate B, or negate some value, right? I think. So if you have this, then instead of having an expression add negate value, you can basically do this instead. So first of all, let's clean up that stuff, etc. And now here we could basically say sub, right? Well, subtract, right? Yes, subtract A and B. And in fact, we shouldn't clean up these right now. We're gonna reuse them, I think, if I'm correct. Oh, unfortunately, I think I cannot reuse B. But like, can I say something like, I don't know, how would you do that? I don't think that's even possible. Well, I mean, I do need the negate. I need to find out how, if B is a negate. Interesting. But what's up right here, first of all? Found expression? What are you talking about? Well, actually negate does gives us the expression, isn't it? Yeah, my bad, I think. Okay, let's get this back here, right? So this is your B. Okay, so this is U size, yeah. And then here you have an expression. So B just needs some dereference here. For A though, for A we have to allocate and stuff like that, which suck. But can we actually even do it? That's the good question. Cannot move out of. Cannot is because it's also. Oh my god, never mind. These borrow checker problems really suck. Anyways. But I think you got the point there. But basically, like, if we have an expression, like an add between an expression and after it, and negate some other expression, you can just turn it into a subtract expression and expression. Instead of having two nodes linked together, you would have one node. You would simplify into one. But you can go wild with that as much as you want. But I think this should be enough for now. But yeah, how much we've been streaming for? 1 hour and 47 minutes. Yeah. I would still like to improve the UX of this, of the user. So right now, if anyone wants to use our library, you have to do it like this, which is very weird, very wild. We definitely need to improve that. But honestly, I think right now I'm kind of tired at this point. But yeah, let's just commit this stuff. And actually, let's do some meaningful example here. I don't know. Let's let the AI maybe generate some expression. And we don't want any. Or we could leave one. It's just that the functions is not using the constant folding currently. Yeah, that's true. So actually right now we're gonna remove the functions temporarily for now, because we weren't successful in making that happen. So other than that, that's great. Oh crap, I have to change it everywhere now. Okay. Oh my. Never ends. Okay, cool. And here, you don't want this. And let's just leave this, right? And let's say something like, I don't know, x to the power of 1 plus x to the power of 0 plus, or let's do something times 1. Alright, let's actually do x to the power of 0, which would result in 1. Okay. And let's do it here plus 0 plus, I don't know, just whatever expression there. And you would notice that after the constant folding, it would constant fold these plus zeros, powers of zeros, powers of ones, plus ones, well, times ones, sorry, and it would also constant fold this x right here since we have defined it, and so this would result in 8. So yeah, evaluation, you just get a number directly, nothing crazy there. But if you have some other variable that is not defined though in the constant fold, of course you would have 8 plus y at that point. And there you go. Great. So this whole expression gets down to 8 plus y. So yeah, that was it guys for the stream. That was wild. Had a lot of fun there. We still have a lot to do. Yeah, constant folding and formatting and AST formatting, I guess. Commit. I should have committed before, after we've done with the formatting, but anyways. So sync the changes. Okay, and right now all the code is on my GitHub. There you go. Feel free to contribute if you want to, or open issues, etc. if you find them. And yeah, so that was it for the stream. Thank you guys for tuning in. Thank you for watching. Thanks for Henrik Pereira. I can't spell that name, sorry. And Wo Jigirin. Thanks for coming in, and see you later. Goodbye everyone.